Let us understand the overall process of text clustering. So initially there is feature selection. Now feature selection involves what features are we going to select, what features are we going to look at. That is, are we going to include the stop words or are we going to look at the main important terms? What kind of features are we going to look at? Now we make use of distance so that we understand what kind of features are similar to each other. Then we apply the clustering algorithm on this. After that, we try to understand what is the underlying concept that the algorithm has tried to capture, and then finally we are going to evaluate what clusters have been obtained. So initially we have to prepare the data for clustering, and for this initially text cleaning needs to be done, that is removing of the unnecessary text including punctuation, stop words, special characters, numbers, all these are to be removed. Then tokenization needs to be done. Stemming or lemmatization can be done. Stemming is the process of getting the word in the root form, but in stemming I may not get a meaningful word, but in lemmatization I'll always get a meaningful word when the words are reduced to their basic form. Then there is vectorization. After this, vectorization can be done with the help of backup words or otherwise TF-IDF, word embeddings. These are the various ways in which we can vectorize the text. Then finally, dimensionality reduction has to be done, because now textual data will have lot of terms that is there. So I might get a lot of features, and so dimensionality reduction becomes very important in these cases. So we have majorly two techniques, k-means and hierarchical clustering. Now k-means is dividing the data set into k clusters, and where k is nothing but the number of the number of clusters that the user specify, and here I will get the clusters depending upon their distance from the centroid. Let us look at an example of k-means. See, this is one example for k-means. See, depending, the centroid gets updated every time. And now you can see that there is very little, when it comes to iteration 11, 12, 13, 14, there is very little difference that happens in the centroid. So here it will take initially it will assign some points as clusters, and then later on it will it will check for each and every point and assign it to the nearest cluster. After it does that, it will check the actual mean of the cluster will be recalculated again. That is, these cluster centroids will be recalculated again, and depending upon that the data points will be again reassigned. So this process goes on in an iterative fashion till there is no more difference in the centroid. Means of the cluster indicates the centroid. So if there is no much difference in the centroid, the process stops. One another technique is hierarchical clustering. So in hierarchical clustering, the nested grouping of the data is represented by a tree-like structure. So here I can merge the various clusters that are there or divide the clusters. Now hierarchical clustering can be divided into two categories. One is agglomerative and the other one is divisive. Now in agglomerative, this is a bottom-up method. It will treat each data point as a single cluster, and then it will go on combining the clusters. In divisive, it will split the data points until a stopping criteria is met. See, these are all individual data points. Agglomerative is combining these data points, whatever are similar, to get one final big cluster. So let's say if I'm looking for 5 clusters, I consider these 5 clusters. Let's say I'm looking for 3 clusters, then I divide it here. I divide it at this point, I'll get A, B, C and D, E. Let's say I'm looking for 2 clusters. So I divide at this point, I'll get A, B and C, D, E. So this is Agnes. Now in what happens in divisive is everything, I go on dividing whatever is dissimilar. So everything is considered to be similar. Then whatever is dissimilar, I go on dividing. So I'll get AB and CDE. Then with AB, I'll get A and B. With CDE, I'll get C, DE. With D and DE, I'll get D and E separately. So this process happens step by step in divisive. Divisive is divisive analysis or agglomerative nesting. Agnes or Diana is the name of the algorithm which gets used. Other techniques are expectation maximization. Now this is the technique, text clustering technique, which is based on probability, and here the algorithm can group text data by assuming that the data points come from a mix of different probability distributions. So here it considers the text data, and it is considered that these points come from different probability distribution. Then there is LDA. LDA is latent direct allocation, and this is here the text data is clustered according to the topics. This is a topic modeling method which we are going to see in detail also. And then there is DBSCAN. Now DBSCAN is density based spatial clustering of applications with noise. This helps me to get clusters which may not be spherical in nature. Which may not be having a clear boundary. Like for example, when I say k-means clustering, I cannot form random shapes with k-means clustering, but with DBSCAN I can get other shapes also. Let's say if there is a spherical boundary, that can be done with the help of DBSCAN. So each of these algorithms have their own advantages and disadvantages. So k-means is a good choice if the data set is small to medium, and hierarchical clustering can help if the data set is large and the number of clusters is not already known. EM or LDA may be appropriate if the data set has many features and I am looking to find some kind of latent structure, some kind of hidden structure in the data. DBSCAN is also a good choice if the dataset contains many points which are closely clustered in some featured space regions, and then they are separated by some other points. So initially hierarchical clustering k-means can be started with, and then LD or EM can also be checked. So the right method also depends upon what is the problem and the data that we are looking at. The next step would be to evaluate these clusters. Now for evaluating these clusters, we have certain metrics, and one of these are the various metrics which get used. So there is silhouette score. Silhouette score here a score of 1, the higher the score better it is. It can range from 1 to minus 1 to plus 1. So minus 1 indicates a not a very good score, but 1 would indicate a good score. Then there is adjusted rand index. There is rand index and then there is adjusted rand index. Now this helps me to check the actual label with the forecasted label. Again it ranges from minus 1 to plus 1. Then there is normalized mutual information. Now this understands how similar are the actual labels with what is predicted. Then there is Paulus-Malus index, FMI. This helps me to understand how similar, geometrically similar, I am looking for the geometric distribution over here, how geometrically similar are the actual and the predicted labels. Then we have V-measure. V-measure checks for the harmonic mean between the precision and the recall. It is similar to our F1 measure and classification. Then we have Davis-Baldwin index. Now Davis-Baldwin index checks for the similarity between each cluster and its most similar cluster. So this is like checking intersimilarity cluster information. Then there is Kalinski-Haribas index. Now this checks the ratio of the variance between clusters to the difference in variance within a cluster. So this is basically checking intercluster difference to intra-cluster difference. So these are the various cluster evaluation. Not do we implement all for all the work, but then depending upon the need, we make use of these evaluation methods.